Today, I'm going to talk about how to migrate your databases and how to run fully managed databases on the Alibaba Cloud. Talking to some of our customers and prospects who have their databases deployed on premises, when they consider moving to the cloud, they usually have one of the following concerns. Right? Number one, a lot of people have concerns around the migration process. Is it going to be an easy process? Is it going to be possible or doable in a self-service manner? Right? What kind of impact does the migration have on my business applications? Does this mean that we have some business downtime? And those are fairly reasonable concerns, right? And we need to have an answer for that in terms of the migration process. The second concern that people usually have is, well, although the migration can be self-service in most of the scenarios, maybe 80% of the time, but still there are 20% of the time where my business scenarios are really complex, and I definitely need some help, some guidance from professionals, from a database expert. So how do I get a low-cost database expert service? And oftentimes, when I move my on-premises infrastructure, database infrastructure to the cloud, I want to take advantage of all the elasticity, the security, the high availability, the scalability, all these benefits, all these cloud native benefits. But how do I revisit my architecture? How do I redesign my system? Right? That's a big question mark. And then the third concern that people usually have is security, right? In terms of authentication, authorization, and encryption. When I move my databases in the cloud, how can I go to a centralized place to manage, to configure all the security settings, and not only the security settings, but make it easy to manage multiple databases, multiple roles, multiple policies in a centralized place. So if you have concerns in one or all three of those previously mentioned areas, then you have come to the right place to learn about our product offering on the Alibaba Cloud. So first of all, what is a database? In my view, database is really the key to empower businesses on the cloud. So quote unquote, the real battle for the cloud providers will be in the databases. If you look at the market share number, if you look at the revenue share number, database, it's always a huge chunk of all the revenue for all the different cloud providers, right? So if you look at the position, database actually sits in the middle between the infrastructure as a service, the IaaS, and intelligent application as a service, right? The SaaS layer. Database is right there in the middle. Now, without database, you have your network, you have your storage, you have a whole bunch of VMs, but how do you actually make your data useful? And also, in a very similar manner, on the other side of the spectrum, no matter how intelligent your applications are, without database to store the transaction records, right? Without database to enable the big data analytics, how can you make it all possible? How can you make all the applications intelligent by only having the infrastructure? It doesn't work that way, right? So database is really, it's really playing a key role in the setup here. Now here I want to briefly talk about the evolution of database development from a business perspective. Initially, many years ago, when people started having data, they usually started having a bunch of structured data, a bunch of tables, right? So think of some transaction records in a bank, in a financial institute. Think of a bunch of orders, right? E-commerce order information from a platform like Amazon, like Taobao.com in China, and also inventory management. I keep records of when people place an order, when people complete a payment, when people actually ship the item, when the shipment is delivered, is received, is signed off, and all that, right? So I keep track of all those records in my backend system, and I have all those records placed in the big table, and I start having the structured data. Once I have those data, I'm gonna start having those challenges in terms of data accuracy. How do I know if my data points are accurate, right? Consistency. So when I write into a database and there's a different people reading from the database, how do I ensure the consistency? When different people pulling data out of the database, they always get the same results, right? And then how do I make all those possible in the high concurrency environment where there are multiple reads, right? Many people reading the database simultaneously. And also high availability. How do I make sure my database is always available? Because maybe many applications connecting to my database, when there's a disaster, when my data center is done, when there's a power outage, how do I make sure my database is always available? And also, lastly, performance, right? How do I ensure all that in a high performance environment, right? Where people expect millisecond level response. So that's where the transactional database, the OLTP system, was born to solve those challenges initially. And over the time, right, when business have a solid solution for handling the transactional records, they started developing new demands. So on one side, it's all around NoSQL, right? Specific unstructured data set, such as documents, such as graphs, such as visualizations. How do I get business insights out of my unstructured data set? And also, think of a semi-structured data set. Think of logs. I've got Apache logs. I've got operational logs. Now, how do I generate business insights out of the semi-structured log data? And to specifically serve those demands, right? To solve those challenges, people came up with a NoSQL and the specialized databases, right? Where the consistency requirement is being relaxed, is not as restricted as the transactional database, but people wanted to get insights out of those unstructured and semi-structured data sets. And on the other side of the house, right, people also wanted to get business insights out of massive data sets where the data is still structured, right? Unlike the log data, the graph data, there's a lot of unstructured data. Well, this time I want to deal with structured data set, but I want to run very complex queries. I want to get the business insights out of it without having impact on my transactional workloads. And that's where people started separating their analytical workloads from the transactional workloads. And that's also why people need a new type of database, usually a data warehouse, to store the data point for analytical purposes, right? Where people can dive deep into the intelligence, into the data analysis. They can run very complex queries. They can do very complex table joins without having noticeable impact on your transactional business. Right? The challenge there is usually performance. Now imagine for an e-commerce platform such as Taobao.com, there is millions of individual sellers out there, and everybody is trying to run some kind of queries against the unified backend in order to understand their own businesses, right? In order to understand their inventory, in order to understand their transactions and the performance and all that. So that is a highly concurrent queries from a platform perspective, right? From a platform perspective, I see maybe 1 million people running millions of queries per second, and I need to provide results for all these people within a reasonable amount of time, and that reasonable amount of time is usually, a couple of milliseconds to a couple of seconds. People do not have patience to wait for a minute to get the results back. And another challenge is how do I make my OLAP system, my analytical database, to be fully and seamlessly integrated with my transactional database. And that's sort of people dive into and develop a new type of database to solve those challenges. And above all, there's a whole bunch of utility tools that are necessary in terms of managing data transmission. When I need to move data from A to B to C to D across my source and target databases, how do I actually make the transmission work? How do I sync up the source and target databases? How do I migrate a full data set as well as incremental data sets? And those are the challenges that needs to be solved under this service and management umbrella. And also, maybe people have concerns about data backup, right? I got database, I want to roll back to a given point in time when necessary. How do I handle backups? How do I handle restores? And also, how do I handle management? I'm specifically talking about centralized management. When I want to manage a whole bunch of authorization policies, a whole bunch of user roles, how can I go to a centralized place to manage all that, right? And that's how people develop the utility tools to solve those individual challenges. Now, if you look at this big picture, right, with all those development, all those new business demands, Alibaba Cloud has developed a whole bunch of products and services and has become the world leading database provider. If you look at Alibaba Cloud database from the following aspects. Number one, looking at it from a market share perspective. In Asia Pacific market, we are the first. We are the number one market leader, right? And there is no doubt, right? That's a solid number one. Now, if you look at the global cloud database market share, we are number three, right? We are behind AWS and Azure, but we are a strong performer, and we are a very strong challenger with a growing business demands. And the second aspect is, right, remember we talked about all those challenges, and Alibaba Cloud is fully committed to offering solutions to all kinds of different challenges as we talk to customers, and we keep providing and building and improving our products and services. As of now, as I speak, we have over 26 products and services covering the transactional databases, analytical databases, the NoSQL databases, and also utility toolings for public cloud, private cloud, as well as hybrid cloud. Now for cloud native database, specifically we have a PolarDB. So this is a next generation cloud native transactional database. It is fully compatible with MySQL, Oracle, and Postgres from a SQL syntax perspective. I'm saying this is a fully compatible, I refer to 100% compatibility because the SQL parser layer, right, the syntax handling, the part is taken directly from those databases, right? So there is no 95% compatibility. It's always 100%. And in terms of performance, PolarDB is capable of handling or providing 1 million query per second, and that is 6 times faster than open source MySQL, right? And also at the 1/6 cost of the traditional commercial database. In terms of the storage, PolarDB supports up to 100 terabyte of storage with automatically workload elasticity, right? When you have a higher workload, the storage just scale up as necessary. And when you don't have that much data, it scales down, when that much storage is not necessary. So you don't have to pay for all that, right? So scale up and down automatically. And we can support up to 15 databases for one setup. So that's aspect number 3. And number 4, we also, one of the key offering is the high performance real-time data warehouse, which is the analytic database. And this is also compatible with MySQL and Postgres SQL syntax. And it's capable for providing a very comprehensive analytical capabilities. And you can imagine, when people have highly concurrent SQL queries and everybody is expecting, millisecond level response, such as in the e-commerce scenario, right? Such as on Double 11, a lot of sellers in China, everybody wants to see a result back in a matter of seconds and milliseconds. That's made possible, and that is supported by Analytical DB. And the last aspect is Damo Academy and the Research Foundation, right? So we hired researchers and data scientists all over the globe to keep innovating and keep developing new technologies, right? In terms of security, in terms of self-driving database, self-sensing database, and all that. So if you look at these numbers, we have successfully helped over 100,000 enterprise customers, enterprise users, and they have successfully migrated over 400,000 databases to the Alibaba Cloud. And year-over-year growth rate is 115% if you compare 2018 to 2019. right? And during Double 11 on the 2019, we supported or we provided up to 491,000 TPS, and that's a huge number. So the key technology breakthrough, 2019 Sigmoid conference, Alibaba Cloud database product and solution portfolios, and this was presented by Dr. Feifei Li, who is the vice president leading the whole kind of database team at Alibaba Cloud. So this is the cornerstone. This is the foundation to really unleash the analytical and the transactional power to support the workloads on the Singles Day in China on Double 11. And another technology breakthrough I want to highlight is the real-time analytical database ADB was ranked #1 on TPC DS benchmark, right? As of April 2019, this was ranked as #1 from a performance perspective. As you know, that TPC.org has the strongest reputation worldwide in terms of validate, audit, and publish benchmarking test results for all sorts of database products. So the whole idea is, for people who decide or who wanted to migrate to the cloud is to do more with less, right? To show you some real data points, right? This is what we mean by doing more with less. Within Alibaba, we have over 100 business units. Think of Taobao.com, think of Tmall, think of DingTalk, think of the food delivery service, think of the new retail service, think of Lazada in Singapore, in all those places, right? We have video service and all that. Putting all that together, we have over 100 business units. And for each business unit, there's tons of databases, right? Thousands of databases. At the end of the day, at Alibaba, we have over 1 million databases. Take a second to think about it. Over 1 million databases. Now, how many database administrators you envision to hire in order to manage and maintain that 1 million databases? Well, at Alibaba, that number is smaller than 50. We have less than 50 database administrators to manage over 1 million databases, right? So effectively, with less human labor, with less machines, you can manage all sorts of databases, and you can get high availability, security, stability, scalability, and performance on the cloud. So that is the benefit of migrating the entire Alibaba infrastructure to the cloud, right? To cloud databases specifically to take those advantages. Now, from a customer standpoint, if you think all that makes sense and you want to learn more about the Expressway to migrate your database infrastructure to Alibaba Cloud to take advantage of the fully managed database services, you can continue listening to this talk, and you can learn some of the challenges that we have learned over the years from other customers. And if you have similar concerns and similar challenges, and here's the solution to solve those challenges. The very first challenge we heard from people is, how do I migrate my database infrastructure to Alibaba Cloud with minimized the business downtime and the zero data loss? I want to have the guarantee that there is no data loss. Right? The challenge there is really, everybody can do sort of a full table migration. It's just a matter of performance. But how do I handle incremental data migration, right? So when I migrate my data to the cloud, during the migration process, I've got incremental data generated on the business side, right? How do I make sure my source database and my target database are always in sync, right? So when I decide to switch my business applications, within a couple of seconds, there's no data loss, and I can maintain a healthy condition for my business. So here's our solution, right? Migration with minimized business impact is not optional, it's a must. We realize this is a strong business requirement. And our solution to solve that is to provide a migration mechanism, and not only a mechanism, but a self-service product called Data Transmission Service. With Data Transmission Service, what you can do is follow the 3 steps here. Right? The first step is you can migrate your schema objects, your metadata, right? And then after the migration of your schema objects, your metadata, and then you can begin migrating the full tables, right? The full data sets, all the existing table. And while you migrate the existing table, behind the scenes, we have started a process to capture the incremental data, right? So starting from here, you have started migrating the full tables, but for all the incremental data, it's being captured by the data transmission service. So when you are done with the full table migration, all those incremental data can be also migrated to the target database, right? So taking step 1, 2, and 3, after step 3, the source database and the target database are fully in sync. At this point, you can decide either to shut down the source and keep only the target database and quickly switch your business application, and you have like minimize the business downtime, usually a couple of seconds. Or you can keep both source and target databases, right? And some of your business logics might be still pointing to the older database, and you can gradually migrate your business functions and applications to your cloud databases. But no matter what you like to do, the two databases are always in sync, right? And you have zero data loss in the entire migration process. So as I mentioned, the data transmission service, DTS, really provides a highway or expressway to migrate and move all of your data from your on-premises deployment to a cloud deployment, right? So this helps you migrate metadata, full table, and also incremental data. And we support over 10 plus source databases and 10 plus target databases. If you look at the architecture briefly, this is how this works. We have an evaluation module, right? So when you start the migration, we're going to evaluate, how long this is going to take. Is there any potential risks? Do you need to do any additional operations on your schema objects to ensure a seamless migration? And at the end of the migration, we have a data validation module to make sure that the two databases are really in sync, right? To prevent you from initiating the migration process but losing data in the process, right? So this is a validation, a strong validation module. Now in the middle, when you do a full table migration, you can go from here, the full table migration, and you can embed ETL functions, right? I can shift data, I can apply some SQL queries and SQL functions, and then deliver data to the writer module in order to write to the target database. And for the incremental data, before you connect those incremental data to the ETL script, to the ETL functions, you can decide to store those incremental data in a DS store, right? So think of a DS store as a broker service, right? Similar to Kafka, which allows subscription, right? Which provides a subscription SDK so that other applications may be, another target database that is not yet supported by DTS. Well, you can configure that to subscribe from the D store, right? To get those incremental data directly via the subscription SDK, right? So this allows you, to go with whatever database you have. It's not going to be limited to, what's supported on the roadmap. Of course, we're going to keep adding targets and sources to the roadmap, but for those that's not yet supported or a self-developed database, you can still use data transmission service for migration purposes. Well, then the second challenge that oftentimes we hear from people is, well, how do I shift to a cloud native architecture, right? For complex business scenarios where I'm looking for a low cost expert guidance. Where can I get those kind of guidance? Right, that's why we want to briefly talk about making product recommendations and implementing the best practices by the database architect team. Now, this team is fully prepared and is very well positioned to provide services with years and years of experience accumulated in different industries. In the e-commerce industry, in the finance industry, in the news and media industry, across all different industries. So essentially, from a user standpoint, no matter which industry you come from, we can always find the right combination of industry knowledge as well as database knowledge and assign people to work with you to provide the best possible recommendations. So this was one customer story. For this customer, before they migrated to Alibaba Cloud, they had this following on-premises database deployment. So they had a web server. This is a customer in the e-commerce industry. So in that web server, they had a whole bunch of functions all handled and combined together in that web server. So they handle product-related requests, inventory, orders, and users. And they allow their customers to use a browser to connect to the web server to issue those kind of queries. And they leverage a middleware to handle those queries and to interact with a single MySQL database instance behind the scene. And as you can imagine, the MySQL database instance becomes a bottleneck during a peak time usage. So for example, during a Black Friday sales or Double 11 sales, when the transaction suddenly creates a jump, right? There's a big spike. Their customers have to wait for seconds to minutes before they can actually continue with their ordering process, right? And their customers were really pissed off. They were not satisfied with the whole kind of transaction handling, the performance bottleneck. And after we migrate this customer, we help this customer migrated to Alibaba Cloud. They were specifically asking for some expert guidance to redesign their architecture in the cloud in order to adopt a cloud-native architecture. So let me walk you through the couple of steps that we have taken, and the database architect, the team has been working with this customer throughout the entire process to provide those recommendations step by step. So step number one was recommended for this customer to adopt a microservice architecture. So instead of a unified web server to handle all these different functions, it was recommended to split the services into different containers, and they can deploy product services in one container, inventory services in a separate container, so on and so forth. The benefit is the query per second would be dramatically different across the different services. As you can imagine, the product services and orders services, right? So one product can be ordered hundreds of times per minute. So orders definitely need more scalability than product, than inventory, and also than users, right? So orders is the heaviest service. Now, when you split vertically your services, then you can scale separately and individually. And then the second recommendation was to really split the MySQL database into multiple databases. So each service container, each microservice has a dependency or connected to one database separately. Now you can scale those databases on demand, right? Depending on the services you are running. That's the second step. And then the third step moving forward is to separate the transactional workloads from the analytical workloads. So as I sort of mentioned previously, maybe all these store owners, the e-commerce sellers wanted to issue a bunch of analytical queries to the database to get some business insights. So when they want to issue some promotions, when they want to issue a refund, when they want to understand the consumer behavior, all those queries are going to be hitting analytic database instead of the transactional database. By splitting the analytical workloads from the transactional workloads, your transactional database becomes more resilient, and you can provide a more reliable and stable service to your consumers. And after that, another recommendation was to replace all the distributed MySQL database with a PolarDB, and that is a truly cloud-native transactional database in order to provide the ultimate elasticity. So for people who use PolarDB on the cloud, they didn't have to worry about scalability, right? So all these microservices are writing data into the shared PolarDB with the shared storage, and you can scale up and down automatically, right? You don't have to manage multiple MySQL instances separately. If you go back to this architecture, this means you have to plan ahead of time. You need to know what kind of resources you need to put for each microservice. Maybe for product services, you need a database with 1 terabyte storage. For order services, you need a database with 50 terabyte storage and all that. You need to plan ahead. Now, when you need to sort of scale your database up and down, it is not a seamless process. There is going to be some business downtime, and you have to redesign the database structure and database tables. Now with PolarDB, you don't have to worry about all that. It's a shared storage. So let's take a closer look at a PolarDB architecture to understand how that is achieved at the technical level. So imagine I have 3 different physical servers, right? And each physical server could be 1 machine. And each physical server can run multiple database, right? And multiple containers. And those databases can be running in the VMs, the containers. So in this case, we have 4 databases, right? There's a DB A and B and C and D. And for database A, I actually have multiple nodes. I have a sort of a master node to handle read and write, and 2 worker nodes for read only, right? We have 2 read only worker nodes and 1 master node for 1 database, and then 3 other database instances. And all these 6 database instances are connected to the shared distributed storage, right? So this is really a decoupled compute and storage architecture to provide the ultimate elasticity. If you take a closer look at the architecture, PolarDB really has 3 different layers. There's a Polar proxy layer, there's a PolarDB SQL engine layer, and there's a Polar store layer. Specifically for this PolarDB SQL engine layer, this is 100% compatible with MySQL 5.6 or 8.0, or Oracle and Postgres, right? We provide full compatibility, meaning that depending on your ecosystem, depending on the preferred SQL syntax, you can choose a PolarDB version, right? Maybe you go with MySQL PolarDB version, and then the SQL engine, the SQL parser, it's exactly the same as open source MySQL. Therefore, we can provide 100% compatibility. So take one step further. If you look at from a SQL query execution perspective, when you have a query coming from an application running on an ECS, which is a VM, maybe this is a e-commerce function for inventory query, and that query is issued from the ECS. First, the query arrives at the Polar proxy layer and will be routed to one of these databases, either read-write or read-only. And then the kernel, the database will be connected to the Polar store to read or to write to that Polar store or to read from that Polar store. And that'll be all handled automatically, right? Without you, this becomes transparent to the end users. Or you can sort of work around the Polar proxy, right? Maybe you want to configure specific specific proxy strategies. You want all the maybe specific queries to be sent directly to one of the databases, and a bunch of other queries to be routed to another databases. So you can either go with the smart, intelligent proxy strategy that's built into PolarDB, or you have the flexibility to manage the proxy strategies yourself on the cloud. Now, the next generation, right? The limitation for this PolarDB architecture is for the distributed storage. Number one, the distributed storage size can go up to 100 terabyte, right? So that's a huge, huge storage. Usually people don't use that much, right? They don't keep over 100 terabyte of data in their transactional database, right? When data becomes colder, they usually have some sort of scheduler to move the chunk of colder data to analytical database, to a data warehouse for analytical purposes, right? They don't have to keep all those data in the transactional database, but still there's a limit, right? That is 100 terabyte. And in terms of the database, the compute nodes that is reading data or that is writing data to the distributed storage, you can have up to 15 database replicas. You can have up to 15 database instances. Now, when you have more requirements, maybe you have even more complex business logics, you want to configure more databases, then you need to go with the next generation, which is cloud native plus a distributed system design. And this is on the roadmap, and this is called Polar X. So essentially, for each of these, this is one Polar DB as is right now. You have a shared storage that supports up to 100 terabyte of data, and you have up to 15 database instances. But in the same time, you can, this is a scale up, right? You can scale up to that many database instances and data storage, but in the same time, you can also scale out horizontally. You can have another shared storage for up to 100 terabyte of data, another 15 databases, and you can scale out further to the right. Well, the downside is when you scale out, then you have to plan carefully, right? What data to be stored in this storage and what data to be stored in the separate shared storage. It's not going to be as easy to manage, data processing across these distributed clusters, but we make it possible for people, who need more than a terabyte of data storage and more than 15 database instances. So this is going to be the next generation architecture design. It's coming up in 2020. And then that's a quick summary for the transactional database architecture. Now let's take a very quick look at the OLAP, the analytical database, the real-time data warehouse architecture, right? This is essentially, this is a shared everything architecture. And this is going to be a shared nothing architecture. Each of these worker nodes and the compute nodes, they connect to, they have a local disk, right? You have a local SSD and you have a local disk, you have a local HD disk, and you have replications across these nodes. And within one cluster, you can have multiple nodes to write into your storage, local storage, and you can have multiple reading nodes. When you read from the local storage, you're going to read into an SSD cache, and then the query can be performed leveraging data stored in the SSD cache in order to provide the optimized performance. And also there's a multiple coordinators. Imagine those coordinators as the master node to route SQL query and to distribute those SQL query into corresponding either the write nodes or the read nodes, right? Depending on the type of SQL queries. And with that architecture, we are able to provide a comprehensive analytical ecosystem that is compatible with either MySQL syntax or Postgres syntax, depending on which one is used by your business. And this is architecture which allows us to provide optimized performance with a low latency. So usually you can get the results back in a matter of milliseconds or seconds. And you can certainly issue queries in a high concurrency mode. You have a lot of users issuing query to the same ADB backend. It's fully capable to handle up to 140,000 rows per second in terms of writes, and you can expect a millisecond to second level response time. And this is a PB scale data storage and data analytics product. Now, moving forward, another concern that a lot of users might have is how to manage and how to operate my databases. Once I migrated my databases to the cloud, how do I manage and operate these databases in a secure and easy manner? To address that challenge specifically, we had a product called Data Management Service, or DMS, and that is the cornerstone which brings enterprise readiness to all of your databases in the cloud, in Alibaba Cloud. So functionality-wise, DMS provides very basic functions, such as a query interface, such as an interface for user to explore the different schema objects across databases, modify those schema objects and design the schema. So those are the basic functions. And DMS also provides a list of security features, such as authorization management, authentication management, and then it even provides the capability for you to review, not for you, but for the system to review the SQL query automatically to make some recommendations to update and optimize the SQL and then in order to provide a reliable DMLs and DDLs without locking down the underlying tables, and then R&D efficiency. So let's use the next couple minutes to dive deeper into DMS to take a look at some of the use cases to understand more from a security perspective. Given that we don't have a lot of time to go through all these features on the list, I do want to give you guys a highlight in terms of what are the key security features provided by DMS. The first one is called a full stack access control. When you have a database on the cloud, usually you want to configure or you want to protect the database, not only from a data access perspective, right, but also from a API and control perspective. From a SQL perspective, right, when you access your data using select, updates, and deletes and truncates, you want to configure authorization policies for specific roles, who is allowed to issue those kind of queries and who is not allowed. Well, that's sort of a data access link. On the other side of the spectrum, you also want to have control around the API level, right? The control plane. Basically, you want to specify which users have the permission to create a database instance, to drop an instance, to reboot, to change an instance, and all that. So data access link and control access link need to be protected separately. And this is what we meant by a full stack access control. For data access link, we provide the following security protection layers for a network isolation, for access ACL, for account ACL, for account privileges, and then the cloud security level, cloud shield at specific product. So you have all these protections, multiple layers of protections. And for the control link, you can protect your database instance, your database resource at the API level, the RAM level. RAM is a account management system provided by Alibaba Cloud as a whole. And then you can configure those security things for multi-tenants, right? You can assign different roles for different tenants. So you have a full access control, not only at the data level, but also at the control level. So this is one example for a fine-grained, centralized authorization policy management, right? So from a user perspective, I have a set of roles, maybe testers and developers and operators and admin people and business people. And then different people, they supposed to have a different types of permissions to either query the data or to update a table or import and export. And then you can configure a permission period for a couple of days, for 7 days or 30 days or a full year. And you can also choose a permission target. Is that permission policy to be defined at the schema level, at the table level, or even at the column level, right? So by combining the user roles, the permission type, permission period, and permission target together, you can create a very, very fine-grained authorization policy. And you can go to a centralized place to manage, to maintain all those authorization policies over the time. You can either grant, revoke the access to a number of users. You can configure column sensitivity. You can decide who can view specific columns in the table. And you can do either a bulk operations or individual operations, to protect bulk or individual operations. And you can issue overdue notification, right? So when someone's permission is expiring in a couple of days, you can send notification for that people to reapply for a new permission and all that. So this makes the whole authorization management way easier than on-premises deployment. DMS, another key function of DMS is to provide the capability for auditing the operational logs, right? From a developer perspective, whatever you do, whatever operations you issued at the SQL level, at the, for changing your data, for updating your schema objects, for exporting your data to another place, there is a record at the back end tracking those kind of operations. So from auditing perspective, it's with DMS, we provide a multi-dimensional, we allow people to do a multi-dimensional search, right? So you can search a specific type of operation at different levels, at people level, database level, table level, function function module level, and operation time window. So by combining those filters, you can audit your database operations in a very fine-grained manner and in a self-service model. So this is, briefly the SQL auditing capabilities we provide. And in addition to the SQL auditing, right, with DMS, it automatically reviews SQL by scanning your application codes. Maybe you have all these applications, right? When you deploy a new application, this application is gonna be interacting with your database to issue some SQLs. Now, to maintain the stability of your database, it's recommended to, for those applications to connect to DMS, to issue query through the DMS SDK. Now, when the DMS receives a query, DMS is going to automatically review the queries, optimize the queries, right? Highlight those queries that are dangerous, that might be causing some tables being blocked, right? Flag those queries. And then for specific DML queries or DDL queries, DMS can automatically update the query to the optimized format without locking down a table. Right, so that's essentially to provide the DML operations stability. So essentially with DMS, we are able to provide a full lifecycle management for all of your databases on the Alibaba Cloud. So the key functionalities cover the following aspects: performance diagnostics and optimization, SQL review, right? Review the code, review the SQL embedded in code to make sure the stability of your databases in production. To optimize SQL queries, to enable data masking, to enable real-time data analysis through DMS, and then and many more functionalities. So given the time constraint, we don't have to go through each of these functions, but just wanted to give you guys an overview. So if you're interested in one of these areas, either OLAP, OLTP, or management and security capabilities, feel free to reach out to the Alibaba database team, and we will definitely help you through the entire migration process to ensure a seamless and optimized user experience, right? Seamless process with optimized user experience. All right, thank you so much.